So this is a little Highland 30 volt 1 amp adjustable power supply kit. Now it is current limiting. In other words, in addition to having a voltage adjust knob, it has a maximum current output knob. $8, depending on where you buy it. It's a nice, simple little kit. I think it'd be a great first-time kit. Well, as soon as I got it, I sat down and made a bill of materials. Everything's pretty straightforward. I made a sheet showing the principal component pin connections. I traced the schematic. Now, the part numbers I've assigned are just my part numbers. And I made a board layout with component values, which are on the PC board, but also the component designations that I created that work with the schematic and the bill of materials. Along with this kit, you need to supply a transformer, no more than 24 volts, and it's sufficient to supply a 1 amp transformer. And if I look at the schematic correctly, you could supply it with a DC power supply. For example, a computer wall connected supply. As is common with these Chinese kits, we have a nicely done printed circuit board, double-sided, silk-screened, solder masked, 4 mounting holes for mounting the whole assembly to a surface. The second thing, in addition to a transformer, will be needed a heatsink. Now, this fan and heatsink was sold on Banggood as a companion to this, and as well as some other Highland supplies. The recommended fan, at least the one that comes with the heatsink, is very small. The heatsink apparently mounts here, and then if you don't want the thing to slide around on the board, you will have to supply some sort of an enclosure. There is no hardware supplied with the components, except for the mounting hardware for these potentiometers. It's up to you to get knobs for the potentiometers. I think in addition to what we've talked about so far, I'm going to supply a socket to mount this 8-pin dip. I'm going to assemble the kit and check the bill of material against the actual stuff that came with the kit. Here's the board with all of the resistors and one lonely diode. Now this is a glass diode and it's a 12 volt Zener. It's the only glass diode in the kit. No surprises with the resistors. It was the exact number that are on the bill of material and as verified by filling the holes. I hope there's no more resistors. Well, there are. There's 2 potentiometers. But there's no more fixed resistors. There is one, I think it's a 1 watt. What do I have down here? Okay, I'm calling this a 1 watt resistor, and all the rest are identical then. And these are my QRP Me assembly blocks that allow me to flop it over and solder it. I guess there is one more resistor. This ceramic resistor. At this point, I've got all of the board-mounted components installed, except for the LM317 and this LED. Now this LM358, I've got a socket for it. Last thing I'm going to do is mount this. Well, the last thing I'll do is mount this. There's a reason for that. Now I'm going to mount this. Well, first I need to mount the heatsink. I'm going to use some shorter M3 screws. These happen to be recessed hex head screws or Allen head screws. Recessed hex is probably the better name for them. And I'm just used to dry fitting all the screws. That's a gunsmithing habit. Now I don't intend to insulate the 3-terminal device from this heatsink, and so this heatsink will be at some potential, either input voltage or output voltage. Depends on whether this 3-terminal device is positive or negative output. There's some exposed silver plating on, or tin plating, on these holes that I'm going to use for screw holes. They're not connected to anything. Now that this hole's drilled off center, if I use it in this position, the leads will barely go through the circuit board. If I use it in this position, the leads will not go through the circuit board. So I need to install it. And incidentally, these are the tapped holes. These are not tapped. Once the heat sink is installed, good and tighten. We'll drop this into its mounting holes, and then we'll raise it until it is in position to receive the screw. Now that that's all in position, tighten down, square, I'll proceed to solder the legs in place. So there we go. Plug in this and I'll power it up. So this is a 24 volt 1 amp transformer. Don't know if you can read that or not. And I've got it hooked into my bench cord. And I'll plug it in and see if we get a smoke. Try to stay out of the camera here in case it does go up. Alright, well, nothing overtly bad happened. You won't see this meter, but I guess we need to set the meter to volts. And there's nothing there. And there we have 28 volts. So 28 volts down to 0. And it's negative. Why is that? Well, it's because the plus is down here. So I've got the voltmeter hooked up here, and I've got a dummy load here. Turn the dummy load on, and it looks like it's drawing a 1/2 amp. And so it folded back. I hit the current limit. Now the LED's not here to light, but I'm hitting the current limit. So I can I'm going to set this current a little less than maximum, and then begin to increase the load current. And you can see it fell back there. Okay, so it's not quite. I'll turn the current limit up full scale, which should be around 1 amp. I'm around just folded back. So I'm right around 1 amp. I'm within 1/10 of 1 amp. And it's still at rated output voltage, which in this case is only 20 volts. But let's look at the transformer once. So the transformer at 1 amp the 1 amp transformer is still making 25. But I'll bet the LM317 is putting itself into limiting mode. Take the current load away. So the transformer at no load is 29 volts. So it's dropping 4 volts. That would explain the output going down to 24 volts. But without a fan, I'll bet this heatsink is causing the LM317 to go into the current limiting. So I'll have to jury rig or permanently attach the fan.